Okay, let's consider f, so the function f such that x is converted into negative 1/2 x plus 5. So on the same axis, let's graph the line y equals x, this function f, and the function f inverse. And we'll plot that function f inverse by taking some points from function f, and we'll interchange x and y to plot those new points so we can draw the line of f inverse. So first I'll start off with graphing the line y equals x. If I can do this again to some degree of accuracy, that would be great. And let's see here. Okay, great. Now I'm going to draw the function 1/2 x plus 5, meaning it's going to be going through 5 and is going to go down 1 and over 2 here. So let's see if I can draw this. Hopefully that is about right. And I'll extend it up in this other direction also to the best of my ability. Okay, so that is the function f. Which is negative 1/2 x plus 5. So now, what we saw in the last slide was that the y-intercept of the function would be the x-intercept of the inverse function. So for the inverse function, we're looking for the x-intercept of 5 here. And because of the function having a slope or gradient of negative 1/2, then the inverse function will have a gradient of negative 2. And let me just work that out. Actually, I'm going to just cheat a little bit here. We can find f inverse, the function of it, in a second. Actually, you know what? I'm not going to cheat just yet. Let's take a look at some of these points and then plot some of the points. So this is point 0.5, and here is the interchanged 5,0. Here is the point 2,4. So the other point would be 4,2 on the inverse function. Here is point negative 2,6, and here is point 6, negative 2. Okay, so those are all points on the inverse function, and then so now I think I have enough points that I'm going to graph this, say, in mauve, if I may use the word mauve. And then I'll just see if I can graph this through those points the best I can, and then extend it down this direction also. Okay, more or less like that. Okay, so this is the graph of, and I got a thin f inverse of x, which is negative 2x. Sorry, 2x plus 10, I believe it is. And I'm just kind of guessing there, but we'll take a look at that in a second. So those are the two graphs. There's the original graph f of x equals negative 1/2 x plus 5. Here's the graph of f such that x equals negative 1/2 y plus 5, keeping in the notation that we saw earlier, where we're interchanging x and y. And here's the graph of y equals x. Okay, so now for part B, we're to find the function f inverse using coordinate geometry and the gradient of f inverse of x from A here, and then variable interchange. So let's find the gradient, and we just need to find 2 points. So let's use point 5, 0. And then another point here would be 6, negative 2. And then we can 0 minus negative 2 is 2 over 5 minus 6 is negative 1, so the gradient is negative 2. So then the formula would be y minus something over x minus something equals negative 2. And we just use any random point just to kind of make things easy for ourselves. So let's do y minus 0 equals x minus 5. Multiply both sides by x minus 5, so we get y equals negative 2x plus 10, which is f inverse of x. Okay, and now if we're going to use variable interchange, what we're going to do then is we're going to start off with f of x. Actually, let's change that to a different color just for fun. Let's go with green. So f of x, as we know, equals negative 1/2 x plus 5. That's the original function. We're going to change this to y equals negative 1/2 x plus 5. Now we're going to interchange x and y. So we're going to say x equals negative 1/2 y plus 5. And now we're just going to solve for y. So we're going to subtract 5 from both sides. So we get x minus 5 equals negative 1/2 y. And then I'll multiply both sides by negative 2. So I get negative 2x plus 10 equals y. So f inverse has been confirmed to be negative 2x plus 10. Just like over here. Okay, so this is using coordinate geometry, and this is using variable interchange, interchanging the x and y values and solving for y. And the last thing we have to do is check that f composite of f inverse of x equals f inverse composite f of x equals x. So we have the two equations. So f composite f inverse of x equals f of f inverse of x, and f inverse of x is negative 2x plus 10, and f is negative 1/2 x plus 5, so I'm going to have negative 1/2, and now I'm going to substitute in negative 2x plus 10 in for x plus 5, multiply this negative 1/2 in, so we get x minus 5 plus 5, and that equals x, just like we wanted. And we can do the same thing. I'll change pens again here. So now we'll do f inverse composite f of x, which is f inverse of f of x. And that gives us f inverse of f of x is negative 1/2 x plus 5. And f inverse is negative 2x plus 10, so we'll start out with negative 2. And then for the x, I substitute in the negative 1/2 x plus 5 plus 10. And then I multiply this negative 2 in, so we get x minus 10 plus 10 equals x. So therefore, it has been confirmed that f composite f inverse of x equals f inverse composite f of x, which equals x. So both of those have been confirmed down here.